Alright, in this video we're going to continue solving equations with radicals, but this is a slightly more advanced version of that. And the reason being is because now instead of having one radical, I have two radicals in this equation. Okay. Now in the first one, the idea was if we only had one radical was to isolate a radical and then square both sides so that I could undo the radical. However, in this case, if we do that, if we just go ahead and start by squaring it because all of the radicals are on one side, what we'll end up getting is this term times itself in a squared fashion. I have 2x minus square root of 4x minus 3. Now what will end up happening is I get 0 on the right side, but now as I do my double distribute, what I end up getting is a term in the front with no radical, right? Because I've got 2x, 2 times the square root of x times 2 square root of x, and those square roots will more or less cancel each other out. Same thing when I multiply the last two terms together, minus 4x minus 3 and minus 4x minus 3 together. But when I multiply these two terms in the middle together, I'm going to get a term in the middle that ends up with another square root. While we could go about doing it that way, it's going to make the process a little bit longer, and it's going to start introducing some larger and larger polynomials that are going to be difficult to deal with. So let me show you a slightly better way to do this. Instead of trying to get all of the radicals on one side, I'm going to go ahead and split them up into two sides. So what I'm going to do is add 4x minus 3 to both sides. That turns into a 0. Now I've got 2 square root of x equals square root of 4x minus 3. Now if I square both sides, you'll notice on the right side I have the entire right side underneath a radical, then I square it. So that undoes the square root operation and leaves me with just 4x minus 3. Now, a similar thing happens to the right side, but I have to remember that this squared, I've got a exponent rule that tells me this too applies to both the 2 and the square root of x inside of there. So the 2 squared is 4, and then the square root of x squared undoes each other, and I'm just end up with an x. So now what you end up getting is 4x equals 4x minus 3. So now I'm going to minus 4x from each side. That ends up being a 0. I got negative 3 equals 0. Now, we've successfully gotten rid of both radicals on the other side, but now what we see happening is the variables cancel out. I'm left with 0 equals negative 3. Here we have to go back to solving equations from a while back and remember that when this happens, when I have an untrue statement or an inconsistent statement, right? I know that 0 does not equal negative 3. So in this particular case, we would have no solution. Now, if we were to have a algebraic solution, we would then have to go back and plug it in and check for extraneous solutions, just like we did in the previous video. Now, I want you to look at this next example here and try this on your own. A little bit tricky because now I have 3 radicals. Give you a hint, just try squaring both sides and see where you get. All right, pause this video, try it on your own. All right, now that you've had a chance to try this on your own, remember the hint was let's just square both sides and see where we get. This is going to introduce kind of a different idea here. I'm going to show you what I'm talking about here in a sec. So if you'll notice, the entire right side is underneath the square root sign and it's being squared. So I know that those two operations are undone and I'm left with x plus 8. Now a little trickier on the right side. So I have square root of x plus square root of 8 squared. Okay, so I have this binomial twice. A lot of times what people want to do is they just say, okay, I square that, that undoes that, and that undoes that, and I'm left with just x plus 8 on the right, on the left side. That's not accurate because I have to square that binomial, and it's going to give us a middle term. And we have to then distribute here, which is going to give us the square root of x times the square root of x, which just do a little side work. So I have the square root of x times the square root of x equals x squared of x squared, which then I know, okay, those operations undo each other, and I'm left with just an x. Okay, so my first term is just an x. So kind of a shortcut you can think to yourself is, okay, anytime I have the exact same number, squared, right? If I have 1,001 square root times square root of 1,001, I don't want to take 1,001, square it, and then find the square root of it. I just know, okay, up here, I have the exact same thing, like exact same square root times itself. So what it just simply becomes is what is underneath the radical. Okay, we can kind of shortcut that there in an effort to speed things up. All right, so now let's go look at the next one. I have the square root of x times the square root of 8. I have square root of x times square root of 8, which is equal x times 8, which is just equal to the square root of 8x. Okay, so I got plus square root of 8x. Then if you'll notice, I have the square root of 8 times the square root of x, which is the same thing as this. It's just the reverse order, but I get that again. So I just write plus square root of 8x. And then finally I have the square root of 8 times the square root of 8, which just gives me what's under the radical, which is plus 8. Now, here's what happens. If you'll notice, I have two like terms, right? I have this and this. They're the same radical, same square root, and the same radicand, meaning what's underneath the radical. So I have x plus 2 times the square root of 8x plus 8 equals x plus 8. All right, let's continue on here. So now I have another radical, right? I've gone from, all right, I had 3 radicals in the beginning to now I've squared both sides and I have only 1 radical. So what I'm going to do is I'm going to isolate this square root sign here by moving everything over. So I got minus x and minus 8, minus x and minus 8. Do one side, do it to the other. Those turn into zeros everywhere, which does something interesting for us. I have a 0 on my right side, and I have 2 times the square root of 8 times x. And if I continue to just go ahead and solve the equation like normal, so now I've isolated that square root, just square both sides. 8x equals 0, divided by 8, that's a 1. So I have x equals 0. Now, if you wanted to have looked right here and just said, all right, the only number right here that makes this entire left side is 0, equals 0, you could have done that. You could have skipped all that if you saw it, but if not, that's okay. Just keep going through your equation solving and you end up getting x is 0. But we're not done. We need to check for extraneous solutions. So I have the square root of 0 plus square root of 8 equals square root of 0 plus 8. So this just becomes square root of 8. Square root of 0 is 0 plus the square root of 8 equals square root of 8. So that does in fact check out. 0 is our solution. Be careful here because 0 is not the same as no solution. No solution means I get an untrue statement like we got right here, which means there's literally no number that makes this equation true. Here, 0 is not nothing. It is an actual number. It is a 0. All right, so be careful when you're looking at the difference between no solution and 0. Hope this video helps. I know it's complicated, so rewatch it if you have to. I'll see you in the next one.